Chapter 11, Organic Compounds. Organic compounds always contain carbon and hydrogen and sometimes other nonmetals such as O, S, N, P, or a halogen. Hydrogen carbons are organic compounds and consist of only carbon and hydrogen. Every carbon atom has 4 bonds. Hydrogen, carbon, hydrogen, hydrogen, hydrogen. And it's an octet, meaning it has 8. Perfect octet equals 8. So 2, 4, 6, 8. Let's identify what's organic. Like we said earlier, it's considered organic when there's a carbon and a hydrogen. So this has carbon and hydrogen, so this is organic. This has carbon and hydrogen again, so it's organic. This does not consist of a carbon or hydrogen, so it's considered inorganic. C2H2 contains again carbon and hydrogen, so it's aorganic. Now moving into the IUPAC names and formulas. We have the number of carbon atoms, the IUPAC name, the molecular formula, the condensed structure. I wrote up to 7, but if you need to refer, you can refer to table 11.2 and page 367. So if you have 1 carbon and the name is methane, and this is your molecular formula, CH4, your condensed structure is just CH4. Then, for example, you have 3 carbon atoms, which is propane, and your molecular formula is C3H8. And then your condensed structure is CH3, CH2, CH3. Then you have another example. Hexane is 6 carbon atoms. The name is hexane. Your molecular formula is C6H14. Then you have a longer condensed structure, which is CH3, CH2, 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 and CH3. All your hydrogens end up equaling 14, and it's hexane because you have 6 carbons. This will help us with the next problems. So keep this right here, like that. Now we're going to learn how to make our structures. So a line angle formula shows a zigzag line in which carbon atoms are represented as the ends of each line and as corners. We have our carbon, which is 1 line, and it connects to our hydrogen. Then we have B, which is 4 carbon, so it's 1, 2, 3, 4. So 4 carbon, 10 hydrogen, and the name is butane. Butane because it's 1, 2, 3, 4. Then you have your pentane, which is 1, 2, 3, 4, 5. Your 5 carbon, 12 hydrogen. Then you have your cyclopentane. Cyclo because hydrogen carbons form cyclic or ring structures called cycloalkynes, which is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 5 carbon, cyclopentane. Now, right here we will be drawing our hydrogen carbons. This is followed with what we just went over. You're going to have to refer to the table in order to draw your propane, hexane, and heptane and cyclopentane. Propane. So bring this table out again. Okay, propane, well, propane was 3 atoms. Our formula is C3H8, and our condensed structure is CH3CH2CH3. So I'm going to be writing right here our condensed formula. CH3, CH2, and our CH3 again. And we would have 1, 2, 3. That would be 1 carbon, 2 carbon, 3 carbon. Okay, now our heptane would be CH3, CH2, 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 and then CH3. We have 1, 2, 3, 4, 5 carbons, meaning heptane. Uh-oh. I meant to put 2 more because it's 7. So CH2 again, CH2 again, and then it's CH3. That equals 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Like this. So this is 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay. Hexane is 6. So we're going to have 6 carbons. We can write it also like this. CH3 parentheses CH2 parentheses 4 and CH3. 4 meaning instead of writing it how I did previously with heptane, instead of writing out the 7, you can just write 4 and it means the same thing. And now we're going to draw our line angle structure, which is 1, 2, that, this, and like that. 1, 2, 3, 4. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6. Okay. Now our cyclopentane is our closed ring one. So that would be like this. CH2, 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 and then CH2 again, and then CH2. Ends up being like this. It's a shape. Moving forward, the alkyl group is an alkyne that is missing one hydrogen atom. Alkyl group is named by replacing the A and E ending with the corresponding alkyne name with YL. Our halogen attached to a carbon chain is named halo group, which is fluoro, chloro, bromo, or ido. In the next one, I will be showing you how this takes place. Our formulas and names of some substitutes. Formula name: CH3 is methyl, CH3 and CH2 is ethyl. Formula name for the second group is CH3, CH2, CH2 is proyl, and then CH3, CH only, CH3 is isoprolyl, which is an isomer. Our third group, the formula name is CH2, CH2, and CH2 is butyl. And then this one is our CH3, CH, and CH2, which is isobutyl. Then we have our other formula names: F for fluoro, Cl for chloro, Br for bromo, I for ido. You can refer to table 11.5 and page 372 for further details. Now let's name these organic formulas. You have 5 carbon, so it would be C5. Hydrogens have 12. We have 5 carbon for this one, and hydrogen we have 12. And then we have this one, which is C carbon 5, hydrogens 9, and we have this different one, which is chlorine, which would just be Cl. Then we have our C carbon 6 and hydrogen 8. Now we will be going over naming hydrogens with substitutes. Methyl cyclopentane. Methyl is the compound structure. Cycle is the ring structure. Pentane is 5. This one. 4-ethyl 3-methylheptane. 4-ethyl in the compound. Methyl compound structure. Heptane is 7. This one would be C2,3,4-trimethylhexane. This would be 2. It's on the second line of the angle. 3 on the third line of the angle. 4, the fourth line of the angle. Tri meaning there's 3 line angles that are outside of the structure. Methyl, the compound structure. Hexane is 6. There's 6 carbon. Letter D, we have 2 connecting at 2. So 2 connect for Br. Di means there's 2 dibromine Br, 2 dibromine, 2,2-dibromine butane because there's 4 carbon. Now we will be learning how to draw the hydrogen substitutes. We have 2-bromo, 2-chloral, 1,1,1-trifluoroethane. That looks like this. Br, hydrogen, bromine, chloride, fluoro. Our methyl Cyclopropane is like this. And lastly, we have our 2,5-dipromo-3-prolactin, which is like 1 bromine, 2, 3, 4, 5. That is Br. And then we have right here 1, 2, 3. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's counted for 1, 2 is our closest, so 2 in the front, 3, 4. This is counting this way is 2 again, so it'll be 1, 2, 3, 4. 2, 5-dibromo, 3 protein. That's it.